And welcome back to the memory section of the Learning, Memory, and Developmental chapter. We're going to cover the memory section now, and as we do, we're going to start off with the most basic memory model that's used today. That is the information processing model of memory. The story of the information processing model of memory goes back to the 1950s and 60s, primarily during the 1960s, in which computer systems started to be used as metaphors for human memory systems. In fact, there was such a metaphorical connection between computer systems and human memory, psychologists referred to this model of memory as the information processing model because they borrowed the term information processing from the study of computers itself. So what you're actually seeing is a model of memory that has been in use since the 1960s and is essentially about the most common memory model in use today. In fact, if you're an undergraduate psychology student, you probably will not see much in the way of alternative models of memory, given that this model works so well. The model itself has three basic components to it: an encoding, storage, and retrieval sections. Encoding is all about getting information in, storage is how it's retained, and retrieval is getting it out. And just to fall back on that metaphorical connection to computer systems, encoding is when you're typing on your computer and getting information into it. Then there's a storage process, which of course uses your hard drive. And then the retrieval process. How do you get information from the hard drive back out? That's a separate process itself. So getting it in, storing it, and getting it out. Encoding, storage, and retrieval. Those are the three components for a computer system, but metaphorically, those are the three components to a human memory system. To take a look at this model of memory, everything always starts with a stimulus, of course, because you're dealing with psychology, and you have to get information into the nervous system before anything's actually going to happen. Now, you go through an area called the sensory register. A sensory register has an odd name, but it's actually a very simple thing to understand. It's very close to just sensation, except if you're dealing with sensation, you're just dealing with the activity of the sensory receptor itself. The issue of a sensory register is the full amount of activity that comes off of the sensory receptor itself. So if you stimulate a receptor and then turn the stimulus off, but the receptor continues to generate action potentials and send those signals back to the brain, that overshoot of activity is largely what the register is referring to. It's the total amount of activity that generates action potentials, sending them back to the brain. And this is an important aspect in terms of the sensory receptors themselves, because the receptors, depending upon how they're stimulated, will send signals back to the brain, always making it more likely that you will detect and remember what happened if more signals are actually being sent back. So of all the things that you think about that you could be stimulated by at any one time, it involves the millions of retinal cells in your eye and all the cells of your ear and every touch and pain receptor in your skin throughout your body on the inside, as well as balance and smell and taste. All of it is being activated at any one time. That's literally tens of millions, if not hundreds of millions of cells that are potentially active at any one moment in time, coming into their own sensory registers. And of all that information that's coming in, most of it is actually going to be lost, because not all of it is actually relevant to anything that you should be doing at any one time. The things that you generally refer to as your consciousness, the things that you're paying attention to, is a tiny selection of all the various sensory receptor activity that occurs for you in any one moment. But of those things that do make it into the sensory register, some small portion of it will move on to the short-term memory system. How that actually happens, by the way, is not very clear, so we would have to spend a lot of time discussing it theoretically, and it's certainly not worth it, and it's not in your textbook either. As you get material into your short-term memory, you're talking about material that can be retained for about 30 seconds at a time, and that's it. And that's why it's called short-term memory. It's a memory system that will retain information for about 30 seconds. Now, short-term memory is very closely associated with what you're actually paying attention to, your focused attention on something. And if you turn your attention away to something else completely, then you may wind up forgetting what you were actually doing inside of about 30 seconds. But for the material that's in your conscious awareness, which is your short-term memory, and you rehearse it, you can keep it there. So rehearsing it is really just repeating it in some way. So if I gave you a phone number to call Walmart, you would have to repeat the 7 digits of the number to yourself over and over again before you make that phone call so you don't forget it, or write it down. But you'd have to repeat those numbers of the phone number to yourself before you get it written down, and then you can stop rehearsing it because you have it written down. You don't have to remember it any longer. Most of the information that's in short-term memory actually gets lost, and that doesn't mean it's going to be unable to be brought back in some way, but it will be lost and then cease to exist as part of your conscious awareness at any one point in time. Rehearsal is what keeps things in your short-term memory. And if material is kept in your short-term memory for a long enough period of time, it will then advance to the third stage, long-term memory. Now, I mentioned a short-term memory generally has a lifespan of about 30 seconds. So that means that anything that you retain for longer than 30 seconds is, by definition, part of long-term memory. But of course, if anything is retained for 30 seconds, 40 seconds, 50 seconds, it's much less likely to be retained permanently than something that may have been retained for an hour or 2 hours or 5 weeks or a year, right? The longer something is in long-term memory, the higher the probability that it'll be retained over a longer period of time. So things can make it into long-term memory, but they might decay and be lost fairly rapidly. For the material that is in long-term memory, you can retrieve it through processes we're not going to talk about and bring it back into short-term memory. So for example, you have a conversation today with somebody, and that conversation takes place over the course of 10 minutes, and it's very important. And because you're essentially engaging in rehearsal, because you're talking about the material over and over and over again between you and the other person, bouncing ideas back and forth, you retain the information in short-term memory for a long enough period of time that it makes it into long-term memory. The long-term memory stores the information, and then a week later, you can then pull that long-term memory back out and then use it in short-term memory with that person as you discuss that conversation from a week ago. That's essentially what's happening. The information has to make it to long-term memory, that it could be pulled back out, reused again through the process of rehearsal, maintained there for as long as you like, just as long as you're rehearsing it, and then if it's kept there for a long enough period of time, any additional changes to that material can then be restored back into long-term memory. Of course, making memories in a long-term memory store does not guarantee that that information will actually be retained there. Almost certainly, you know at this point in your life that there are things that you once knew that you no longer can remember. And that is exactly what information loss from long-term memory is. You move to a new state, and when you try to remember the layout of streets in your neighborhood, you may begin realizing after a few years that you start forgetting the names of some states, or the name of a person that you grew up with, or where you put something, whatever it might actually be. Material that is retained in long-term memory that you're somewhat reminded of because you engage with that material every now and again is constantly being reestablished and secured in long-term memory. But if you wait long enough and never use that material again, it very well may just be lost. And that is something about your memory system that you need to be very aware of, because you'll notice that on the bottom of each of these three stages of memory, it says information lost. And that's telling you that of your complete memory system, you are forgetting stuff all the time. Everything in your memory is subject to loss, and nothing is absolutely guaranteed to be retained forever. So it's a kind of an odd way to think about your memory system, in that it retains things for different periods of time, but that all things potentially can be lost. Long-term memory is just one portion of the memory system we're looking at, but it is the system that most people tend to stress. And when you take a look at the structure of long-term memory overall, you'll see here that there's a particular manner in which information is organized. And this organization of long-term memory does, at this current time, definitely connect it to different areas of the brain, different neurochemicals, as well as different processes. So the categorization system that you see on the screen here is actually very important, but remember, it's specifically for long-term memory. This is not a structure for short-term or sensory register. In terms of long-term memory, information can be stored one of two ways. There's information that you can basically talk about, and there's information about how it gets expressed. Information that is going to be expressed really refers to the output pathways of the memory system itself, whereas the type of knowledge stored generally refers to the information itself. So in a very general hypothetical sense, you can think of storing information and in a particular area of your brain. That's type of knowledge stored. But that knowledge has to get out at some point so that you can prove you have it. The particular pathway that information goes from its location of storage to your language center or to some other aspect of motor control to prove that you can do a dance step that you learned last week is the process of how a memory gets expressed. Those are the two separate systems that you're looking at. Now, in terms of how knowledge is stored, it could be stored in one of two ways. A procedural memory, which refers to a nonverbal memory, a memory that does not require language. So like your ability to ride a two-wheeled bicycle does not require language. Your ability to jump rope does not require language. It might initially when you're learning how to do it, but when you finally get the skill down, it largely functions, or it is stored as a functional process rather than information that you could express in language. The alternative is declarative memory, which is called declarative because it engages the language system, so you can declare that information. And declarative memory can be broken down into one of two areas: semantic and general knowledge and episodic memory. Semantic and general knowledge refer to semantics, the meaning of information. So as a human being, you do live in a world where things take on symbolic value, and that is what semantic information is. General knowledge refers to things like which state do you live in, who was the first president, and so forth. Those are all general knowledge information. And then episodic memory is essentially your memories of life events from your own point of view. So hypothetically, as if you had taped a GoPro to your forehead and recorded your entire day's activities. That is episodic memory. If we move over to how memories get expressed, which I mentioned is largely related to the output pathways, you'll see that there's implicit memory, nonverbal, and explicit memory, verbal. Those are actually directly connected to procedural and declarative memory, respectively. Implicit memory is nonverbal, and it's the pathway out for any procedural memory. And explicit memory, which involves language, is the explicit process out for any declarative memory. And that's the basic layout of long-term memory overall. Explicit memory, which is verbal, which is of course going to be stressed for human beings typically, will engage two general processes, recall and recognition. Recall and recognition are just the ways in which a person will express through words their ability to show that they have some particular memory. Recognition generally refers to a scenario in which you are stimulated by the environment sufficiently so that the thing you have to name is like right in front of you. And then recall is usually a scenario where there are fewer stimuli in the environment, but you have to name them. So if I said, name a fruit that is red, somewhat round, oftentimes baked into pies, and is sometimes given to a teacher, I'm not naming the object. If you can bring that information to memory, it would be referred to as recall. If, however, I took an apple and I actually showed it to you and said, what's the name of this thing? And you called it apple, that would be called recognition. What's the difference between these two scenarios? It's the amount that you're actually stimulated directly. Recall generally refers to a lower stimulation process, and recognition generally refers to a scenario in which there's much more stimulation from the environment to draw back that memory. Is there a clear distinction between recall and recognition? No, not really. It's a general term that kind of is referring to the opposite ends of a continuum of the degree to which you're actually stimulated. Now, retrieval, as I've kind of been talking about, it generally refers to the process by which information is brought out of your memory system. All right, the process by which previous experiences are brought back into working memory. That's the entire retrieval process. And it does fall along those two lines of recall and recognition as I've been just describing. So one way to kind of keep this in mind is that the term recognition generally is used in this sense the same way that you use it in everyday language. So when you say you recognize a person, you would only say that sentence, I recognize this person, because you're actually looking at a picture of the person, or you're actually looking at the person at that time. It's like an example when I said I hold up an apple and say, what's the name of this thing? You are being stimulated specifically by that particular cue. Recall, on the other hand, is a scenario where you must try to eliminate as much stimuli as possible from the environment. Now, can you have no stimuli from the environment to exhibit retrieval? No, that doesn't even make sense. If there's no stimuli in the environment to elicit a memory, then that memory simply will not occur. You have to have some stimulation from the environment to elicit the memory. But if you try to minimize the amount of stimuli, then it's called recall. And recall very commonly is described in terms of essay exams, right? So if I give you an essay exam for all the material we're learning in the MCAT, and the essay exam had one question on it. And that one question was, tell me everything you learned in the MCAT section. Nothing else. No descriptions of chapters, no names of researchers, no category designations, nothing. No history, anything. You simply have to remember the entirety of everything you learned studying for the MCAT, organize it yourself in your own head, and then write it all down. That would be much closer to what you would refer to it as a recall process. Now, as you might imagine, this is going to be much more difficult, and you're more likely to get a lower grade on a recall process like this in an essay exam, simply because the material has to be learned so much more thoroughly that you would be able to recall it with fewer stimuli in the environment, that you're more likely to actually get things wrong. Of course, the alternative is a recognition task where, in a multiple choice test where you're actually going to be faced with, you actually have the correct answer of a multiple choice question right in front of you. You simply have to pull it out of that lineup, right? A multiple choice test is exactly like a police lineup. Which one of these guys mugged you? Well, A, B, C, D, which one of these biochemical molecules is responsible for the Krebs cycle? You have to identify who's the guilty party in this lineup. So the police lineup and the recognition task of a multiple choice test is essentially following the same process. But that's how you need to remember this material. Now, retrieval gets affected by the same things that affect basically all learning and memory. In fact, there's a large grouping of things like the degree to which the stimuli present during learning are present during the time in which you're going to remember something. And in fact, the more likely that stimuli that are present at learning are also present at the time of retrieval, makes it more likely that you will remember it. But if you try to remember something in an environment that's extremely difficult from the material you're trying to remember, then you'll actually have more difficulty. So if, for example, you lived up north and you remember a snowy school day you had, it snowed so much, school was canceled, Christmas was in 2 weeks, and then you go to the base of a mountain in Ecuador during the summertime and try to remember your snowy snow day back when you lived in Vermont, you just literally will have less chance to remember the details of the event. However, if you go up to Vermont during the winter when it's snowing near the house that you grew up in and then try to remember things, you'll remember quite a bit more detail, simply because the conditions you're under during the time of retrieval are much more similar to the conditions that were present when the memory was formed, and therefore there's a higher likelihood that you will remember things correctly. In terms of retrieval, there are a variety of different ways in which this process gets identified. They are all the same recall recognition issues, but these are kind of classifications that identify particular processes that occur in terms of retrieval. One is called state-dependent memory, where in a very much like I was just describing, the environmental event has a significant bearing on the likelihood that you'll remember things. So if you want to remember that snow day and you go back to Vermont and it's snowy, you'll be more likely to remember a point in time earlier in your life. If you want to have a harder time remembering it, then go to the, someplace that's sunny and hot and try to remember the snow day that occurred 25 years ago in your life. In a very similar process, rather than dealing with specific stimulus events in the environment, like literally snow that's present or not present in the environment you're in, you just focus on your mood state. You would call it, instead of state-dependent memory, you would call it congruent moods effect. In the congruent moods effect, because you always have some particular emotional state that's activated at any time, you would be more likely to remember an event that occurred long ago if your emotional state is similar to the emotional state that was present when you remembered the information. So, for example, if it's Christmas morning in your house and you're remembering, or actually you're having a really nice time with your family, you'll be more likely to remember other Christmases when you opened the present or you had family around and you're enjoying yourself. If you're being yelled at by your boss, you're going to be more likely to remember all the times you were yelled at by your boss rather than Halloween or Christmas morning or some other time where you were stuck in traffic. Those issues are less likely to even come to mind. You're simply going to remember more of similar types of events when you had a similar emotional state. So oftentimes you see this in terms of therapy for relationships. If a couple, let's say, goes to marriage therapy because they're having trouble getting along, it is by definition telling you that they're both unhappy, which means they're going to be more likely to remember negative events about the other person, or even to take neutral events and re-describe them as negative. And not because they're purposely doing this, but because their mood state is indicating that the events that they remember were actually more negative than they may have actually been when they formed the memory. As a result, you generally have two individuals who only remember the bad thing about the other person. And one of the things that a therapist will do, which seems very simplistic but is actually very important for therapy, is to try to get those individuals to do something that they both enjoy doing. Something that will give them an opportunity to have a good mood event. And if they have a good mood event, then they'll be more likely to remember good things about the other person or to describe an old memory as positive with the other individual. And that kind of will give a little bit of a kickstart to therapy in the very beginning of the whole process. Now, other than remembering things in this state-dependent or congruent moods process, there are scenarios in which you are exposed to stimuli, but that you don't have the capacity to retrieve them, that you literally have not formed them into memories despite the fact that you were repeatedly exposed to these stimuli. And that's what you call the failure to encode process. Where you see the failure to encode process is usually irrelevant detail on a common stimulus. Well, where can you find that? Well, the details of your credit card, or oftentimes more likely bills that you use. If you've been through your wallet and you know you have a $5 bill, do you remember the serial code on the bill? Do you remember how many letters or numbers are in a serial code? Do you remember who's on the $5 bill? These are all things that oftentimes are largely irrelevant to the use of money itself. Or even I could ask similar questions like, what's written on the back of your credit card? I mean, you may use your credit card every single day, but do you even know what the number of your credit card is, right? The 16 digits. Or is it 16 digits? Is it 12 digits? Is it 20 digits? How many digits do you actually have? I mean, you may be wondering about that right now. But you use that darn card all the time. But there are details about it you simply have not encoded, because it doesn't matter what the digits on your card are. You swipe the card and it works. That's all that matters. You put it back in your wallet and you move on with your day. the serial code on a dollar bill is completely irrelevant. The only thing you need to know about currency is its value. There's a 1 in the corner of the bill, a 5, a 10, a 20, a 50. Those are the only things that you need to focus on. Who's on the 20? Is it Jackson or is it Tubman? It doesn't matter. You won't remember that, and it has no bearing on the value of the currency itself. The only thing you need to know is there's a 20 in the corner of the currency, and that's the only thing that matters. So the rest of the details oftentimes are actually very much lost. And of course, something like this would be relied on by people that do counterfeiting. And it's also a process, even in a more general sense, of everyday experiences that you have in social psychology and dealing with people and being out in the environment. There are many common experiences you have, like driving through the city you're in, or dealing with people at work, that you simply don't pay attention to because they're always there. And when those things change, you're not aware of it and you have no memory for it. That's what the failure to encode process is. Now, it is possible in other scenarios that a person can not encode information largely as a result of disruption due to emotionality. In all things in psychology, there is a usable working range in which things occur. And when you go outside that range, the other events that are occurring may disrupt processing. In one case, in terms of memory, is emotionality. If you are extremely emotional, in some instances, not in all instances, but in some, the emotionality may actually disrupt your ability to form a memory. And so a nice example of this is a clip that I'm going to show you from an interview with Jeffrey Dahmer, who was a serial killer from the late 80s, early 90s. Dahmer is admitting to having beaten someone to death by his own bare hands, but does not remember the event. And he's not trying to deny having murdered the person. He says that basically he had to have done it. It's just that you have to imagine that beating a person to death by your own bare hands is probably such an emotional event that he actually wound up not processing the memory properly and holding it so that the following day or even during this interview, he remembered much of the details of it.
But Jeffrey says in 1984, while living here at his grandmother's house in Milwaukee, his violent compulsions consumed him once again. One night, cruising these bars in downtown Milwaukee, he met a young man and took him to this hotel.
I had put some sleeping pills in his drink to render him unconscious, and was just going to spend the night with him. When I woke up in the morning, my forearms were bruised, and his chest was bruised, and blood was coming out of his mouth. He was hanging over the side of the bed, and I have no memory of beating him to death, but I must have. And that's when it all started again.
And once it started again, you found it impossible to stop.
Right, that's when the obsession went into full swing.
So you see in this case, Dahmer is not denying that he committed the murder, but he doesn't remember doing it. And if that's the case, that he can't remember, then it's very likely what had happened is that the emotionality of the murder itself disrupted the underlying biological processes that are necessary to form a memory, and therefore the memory itself cannot be retrieved because it literally doesn't exist. In the last slide here for the memory section that we talk about, we discuss the false memory syndrome. False memory syndrome, which was actually first discovered back in the 1970s, is really related to much of the things we've been talking about, like the state-dependent and congruent mood memory issues, whereas the environment that you're in modifies what you remember. And in some cases, like with false memory, the environment you're in may cue in different components of memory that are not actually really correct. And therefore, information that's not correct gets embedded with a separate memory that is entirely independent of, but you don't have an internal checking process to make sure that your facts are correct because you are the only person who's ever experienced these things. As a result, a person will start to blend portions of their memory together and then start remembering things incorrectly. Now, when this kind of process occurs in a much grander sense, especially because of the input of a therapist or because somebody is giving you false information and you come to believe an event that is true that never actually happened, that's generally when the term false memory syndrome is actually identified. It really started to take place as a relatively common issue when a very sloppy clinical work, and in fact, you may enjoy this one, oftentimes people that hypnotized their patients because they were using Freudian systems, so that a Freudian therapist or a person who's at least borrowing some of Freudian psychological processes and applying hypnosis as a way to regress a person back in years to try to get them to remember something, which, by the way, is not a real event, but people do it anyway. These processes occurred, and the therapist kept hinting to the patient that they may have been molested or that they may have been part of a satanic ritual. And over time, the patient, who's already emotionally vulnerable because they are in therapy, starts to believe that they were sexually molested or part of a satanic ritual as a child. And then by the time that false memory becomes extremely strong, they may actually go to the police and start laying out accusations. And during the 1980s, this was actually occurring so that a set of parents who gave a child a normal upbringing would eventually one day just randomly get arrested for having sexually abused their child in satanic death rituals in the basement of the house, only to find out later on that that there was a false memory induced by a therapist, and that when you really tried to look at the specific dates and events and try to justify what actually occurred, in many instances, the physical story, like the evidence that was supposed to be there, like the basement in the house that this took place, is actually not even a thing. You know, that there was no basement in that house, or, that so many people would come into the home, but nobody in the neighborhood ever remembers other people coming by the house and so forth. So it becomes a rather difficult issue. And in fact, hypnosis as part of a clinical therapy to try to bring back an old repressed memory is something that is highly questioned now and probably not even admissible in a court of law any longer, given that there is clear evidence for the issue of false memory syndrome. We are covering the human development section at this point, and we're going to start off with a discussion of basic reflexes that occur in infants at the time of birth. As you see from the chart here, there are actually two categories of reflexes that occur in human infants. One are called survival reflexes, and the other primitive reflexes. Survival reflexes are directly related to things that help keep the child alive. So if you take a look at these, obviously the breathing reflex, that will keep you alive. Eye blink reflex, not necessarily keep you alive, but certainly protect your eyes. Pupillary reflex is going to be related to your ability to improve your vision. The rooting, sucking, and swallowing reflex are, of course, all related to eating, and that's definitely a survival issue. The primitive reflexes are a list of reflexes that do not appear to have any particular value today, but the assumption is in previous evolutionary history that these reflexes serve some particular purpose. So, for example, the grasping reflex, which you see with an infant, that if you place something small in their hand like your pinky, they will grab onto it. And in fact, if they grab onto something like your pinky or a skinny stick, their strength of their hand will be sufficient to actually raise their entire body up so that they can hang by their own hand. And this is, of course, right, not something you should try at home because for safety's sake, but that grasping reflex is assumed to have been part of an earlier primate stage of evolution where a mother may have actually been up in a tree with an infant, and that the infant would grab onto the mother's hair so he wouldn't fall out of the tree itself. And you see that in a wide variety of these things, like the swimming reflex, which occurs during the first couple of months of life, where a child will automatically close off his esophagus and produce swimming motions. The stepping reflex is related to early development of stepping. The moral reflex is related to a startle response. The list goes on, but they don't seem to be especially important at the current time. One of the easiest ways to kind of deal with this is to take a look at the primitive reflexes in a video, which is what we're going to do. The survival reflexes are fairly straightforward. You don't really need to see them play themselves out, like breathing, eye blink, pupillary reflex. Those are fairly straightforward. The rooting, sucking, and swallowing are just basically related to breastfeeding. So that's a fairly straightforward story itself. But the primitive reflexes are very much used to evaluate the development of the nervous system at this early stage of life. Before a child has any language and can't communicate to a medical doctor how they feel and what's actually going on with them, a medical doctor will have to evaluate these primitive reflexes to evaluate the proper development of the nervous system itself. Because all of these reflexes, as you're going to see in the video, appear and disappear in a particular sequence, and eventually they will all disappear after about 2 years of age. As a result, a medical doctor has to be aware of these, especially a pediatrician, to know which of the reflexes should be occurring at which time. Because if the reflexes occur out of order, or they occur too early or remain too late, that's indicative of some sort of problem with the developing nervous system. And that, as I said, you'll see here in detail.
Reflexes like the palmar grasp, stepping, Morrow, and Babinski are an inborn automatic response, nature's toolkit to help an infant adapt to the world. Many reflexes, breathing, swallowing, and sucking, for example, have survival value. Other more primitive reflexes like the Morrow and grasping are considered leftovers from our evolutionary heritage. Survival reflexes usually become voluntary at some point during the first year, while the primitive reflexes disappear.
Anthony, go back down for a second. So pretty much losing that. So she withdraws, and the toe goes up and fans out, just like that.
Some reflexes are predominantly related to the nourishment of the infant. Here, in response to stroking at the corner of Aiden's mouth, we see the rooting reflex. 1-week-old Aiden turns his head and opens his mouth. He roots in the direction of the stroking. This helps the infant find the breast or bottle and begin feeding. Sucking is another reflex that helps the infant find food. Aiden will instinctively suck on any object that is placed in his mouth, including the doctor's finger.
Some reflexes are predominantly related to the protection of the infant. Stroking the palm of Mackenzie's hand will cause her to close her hands and fingers in a grasp. The grasping reflex may be so strong that the baby can support her own weight.
The Moro or startle reflex is seen when support for the head and neck is suddenly lost, or in response to a loud noise or sudden movement. Here, 1-week-old Aiden throws his arms out and back in response to the doctor's sudden drop of his hands. The Moro reflex, which should be fully present at birth, begins to disappear at around 5 months of age. Jessipina, who is just 2 months old, has already begun to lose the Moro reflex. Absence of the Moro reflex at birth or reappearance after the normal age of disappearance, approximately 5 months, may suggest damage to the central nervous system.
So she doesn't have a startle anymore. It's gone.
Okay.
She's matured and she's overriding that.
Some reflexes, such as the stepping reflex, are related to postural control. When held upright with her feet just touching a flat surface, 2.5-week-old Olivia appears to take steps and walk. This reflex, which typically disappears at around 2 to 3 months of age, will not be seen again until Olivia learns to walk on her own.
Oh, I'm sorry. All right. Let's do that a little better. Let me hold you this way so people can see you. Okay. So she stands, and there like that. She'll start taking some steps. And you can get it to, if you sort of touch the top of her foot, she'll pick up a little bit there, like that.
Reflexes are also used to identify normal brain activity. Absence, persistence beyond the normal time for disappearance, or the reappearance of a reflex later in life is suggestive of significant neurological problems. For example, the Babinski reflex, exhibited here by Olivia when the bottom of her foot is stroked, causes the big toe to flex towards the top of the foot and the other toes to fan out. The Babinski is normal in children under 2 years of age. After 2 years of age, the presence of the Babinski indicates damage to the nerve paths connecting the spinal cord and the brain.
So as you see there, in a variety of cases, the time period in which these reflexes occur is actually very important for a diagnostic value. And for those of you that might be interested in intellectual disabilities, autism, learning disability, and so forth, many of these early primitive reflexes are actually used as a way to assess potentially symptomology of autism or other types of disorders that may occur later on. Now, in terms of cognitive development for infants, there are a variety of things that infants will recognize that you may not be immediately aware of. One, infants will look at a human face more than anything else that they'll look at even on the day that they're born. And the interesting thing about that is the child has been upside down in complete darkness for 9 months, and they are going to come out of their birthing process and look at human faces more than anything else. And how could that actually happen if they have no experience looking at human beings? And the issue here turns out to be related to the fact that we all have a circuit in our brain that helps us perceive the arrangement of facial features of a human being, and to highlight that in our consciousness more than any other stimulus so far detected. Consequently, even when an infant has poor vision on its first day of life, you can show it a human face on a computer screen, and it will look at the human face more than it would look at, for example, the standard happy face or the upside down boxy face, or even more, it would look at the upside down boxy face more than it would look at a abstracted image like a bunch of paint thrown on a canvas. So there is that. That's another aspect of basic responding that occurs right at the very beginning of life. An infant will respond to its mother's voice more than any other voice. And that may seem odd because they were just born, except you have to kind of back it up a little bit and realize that an infant was hearing its mother's voice as well as other voices in the womb for the last few months of its prenatal existence. And in fact, its own mother's voice more than anybody else's is going to be the one it hears, because as she speaks, her own voice will travel through her own body. And so as the child has ears that will allow him or her to hear, some of the first sounds that the child is going to hear is his or her own mother's voice, as well as the mother's heartbeat and breathing and so forth. But of course, other people that are around mom that speak to her on a regular basis will become voices that the child will recognize and that you can assess for on the day that it was born. There are also some other ones here that are a little bit more confusing given the technical biochemical or neural pathways that are actually involved. But your mother's smell and tastes that she experienced during her diet both influence the child's preferences at that very early age. And so it's, of course, rather difficult to evaluate the degree to which a child will respond to smells or tastes at an early age, but the amount of evidence that exists seems to indicate that children prefer their mother's scent above the scent of other people, male or female, and that tastes that the mother ingested during her diet while she was pregnant are tastes that the child will prefer once he or she was born. And lastly, in this very short section on human development is the aspect of social development. Of the component of parental upbringing, there tend to be identified by developmental psychologists 3 general ways in which parenting takes place. Parenting is seen to take place in 3 categories: authoritarian, permissive, or authoritative. And the terms authoritarian and authoritative are, of course, very similar to each other, which will cause confusion. And you can thank developmental psychologists for that bit of stupidity right there. Authoritarian refers to scenarios in which the parent just makes very strong demands on the child, doesn't give reasons for why they tell the child to do something, but just demands that the child do it. In the permissive parenting technique, generally the children are allowed as much freedom as they possibly can have regarding safety, until the parents start to intervene for the child's sake. And the authoritative is really kind of the one that rides the fence between the two. Authoritative generally refers to scenarios in which expectations for behavior are set and enforced, but that they are not enforced always, that there are some openings for context or special circumstances that may modify the rules a little bit. So what you're really seeing in this case is permissive gives children as much room as possible to do and make decisions for themselves, even though they're only children. The authoritative process sets rules for children, but is a little flexible about their application to some degree. And then the authoritarian at the other end is really just a top-down process where the parents tell the children what to do and that's it. In terms of these types of parenting techniques, you may not see that you're actually any one of the three, and I don't think many people actually necessarily would see themselves clearly fitting any one of these particular parenting techniques across the board for all things. What you tend to see is that these categories tend to exist statistically in more or less likelihood in certain cultures. So, for example, in the United States, the authoritative technique tends to be the one that is most common. In some of the more egalitarian European countries, like Holland, for example, the permissive parenting style tends to be a little bit more pervasive. Now, does that mean that if a little Timmy wants to run into the street where there are cars coming, their parents won't just grab them and pull them in back and say, "Damn it, I told you not to go in the street"? No, of course not. There's going to be some intervention there for the child's safety, of course. Nobody's given a 3-year-old the decision to whether or not they should smoke crack. That's not really what's being applied here. It's mostly decisions about what kinds of things they're going to wind up doing and when. If a parent in a permissive society gives a child chores, it's likely that the child will have to do the chores, but whether the child does the chore immediately, like would be expected in the authoritarian scenario, parent just told you to sweep the floor, so you got to just get that broom and start sweeping, or whether or not the child decides to do it an hour from now is something that you would be more likely to see in a permissive scenario. Parent tells you to sweep, and you kind of take that as, well, before the day's up, I should clean the kitchen, sweep the kitchen out. And that is the way the permissive process would generally play itself out. But these three processes tend to be kind of clustered with respect to cultures. Now, one of the basic questions that you always get in cases like this regarding parenting styles is, which one works best? Well, the answer is none of them. The best parenting style is the one that actually matches the child's personality and emotional capacities. Some children respond to the authoritarian process best, and so that's the best way to raise them. Other children respond to a permissive process, and that's the best way to raise them. And so on for the authoritative as well. The technique of parenting that works best with a child really depends upon the interaction between the culture, the parent, and the child. So there is no universal standard that you could place for a human being to say there's one set process. And in fact, when I say best, what you're really referring to is the situation that produces the minimal amount of strife between parent and child. So with respect to the amount of family arguments that are going to occur, you would minimize them by fitting the parenting style to the child's personality to maximize the flow or the minimization of strife in the family. Whether or not you feel that's important is, again, completely up to an individual and the way they decide to raise their children. It's not like there's a constant that you have to feed a child or an individual has to sleep or they'll wind up with brain damage. Those things are clear and they would happen to anybody anywhere in the world. But in these particular cases, you're really open to a much broader process by which the parenting style would be applied to the child's personality to determine the minimal amount of trouble that would occur. And that ends the topic on human development in this very short section.